You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you.
Greetings, everybody, and welcome back to Data Center Therapy, a podcast from Iboxy Consulting that talks all things IT with a healthy dose of empathy. I'm your host, Matt. I'm going to start calling my neighborhood a segment Yeti. And alongside me is my co-host, Matt Overlay Cozzolino.
Hello, everyone.
In each episode, we dive into the wide range of technologies that make up this beautiful sandbox called IT that we all play in. We share our hopes and dreams, opinions, both positive and critical alike, all with a touch of empathy, because at the end of the day, we all need a seat on that couch. So we are kind of following up still. We're in episode 3 of our on-demand lab series. I almost said hands-on on-demand lab series, so thank you, Kazo.
On-demand,
demand hands-on. I demand hands-on.
There you go.
And so last episode we spoke with our very own Shane Bradley, who is an absolute lion of a man who just, charges forward into any challenge, whether that's the inauguration of the refresh of Iboxy's education classes or cave diving, the lunatic, which I will never be okay with, never ever. Anything he asks the guy to do, he'll do it with aplomb. So Shane, thank you for joining us on that.
Good job, Shane. Bravo. Golf. Hey, wait. Golf.
So we're moving on. Yeah, golf. That's right. We're still in the Masters golf club. Yes. So today, we ended our episode last time talking about hardware and physical tools, actually, which was kind of interesting. But Kazo brought up a good point, sir. What was that? I said save it for the episode. So
save it for the episode.
Go ahead now.
Well, we were talking about woodworking tools, and I made the comment that you can use any one of those tools to cut up a pallet, and that really drives the question of what are you doing with that pallet, and then what makes that the right tool for that. Because I'd argue if I'm cutting a pallet up to burn it in the fireplace or the fire pit out back, a sawzall's perfect, right?
Yeah, so we'll go back to that. We'll dive into that a little deeper in a minute. I guess really it centers around the phrase, the right tool for the job, right? And I think that can apply to almost any job that we're in, but I also think it's not completely analogous between IT and fighting in your backyard or your house with the tools. I think whereas IT, there are a number of ways to do things and a number of ways to do things adequately and relatively efficiently. I would say the wrong tool for a physical job it can be a nightmare.
Yes.
That's the only difference there.
Yeah.
Specifically to the sawzall, not that anybody cares, but I hate the plug-in big. My father-in-law's got a big old Makita. It's like a 10-inch blade, and it's just a bear of a tool, and the blade's so long and this and that I'm like, I just don't like using it. So I bought this little Milwaukee sawzall, battery powered. Obviously, power is not completely all the way there, but it's a much shorter throw. It's like a 4-inch blade. This is great. A little handheld sawzall that's not going to vibrate my chassis. It's terrible. It sucks.
I think
no
to that right tool for the job, you have to actually define what the job is, though, right? And that's kind of what we were talking about on the last episode when we were looking at the class and spinning up the lab and what are we trying to solve. And we talked about working with customers. And yes, we can deploy this thing because it's cool and neat, but as long as we acknowledge that that's why we're doing it, that's, I think, the important bit. Oftentimes,
you're right. I mean, we could have said build a lab. How many different outcomes might that very wide statement have?
Right. Yeah, some Breaking Bad stuff going on. It's a lab, right?
Yeah, right. Yeah, exactly. Here comes Matt rolling up in the Winnebago. I go, whoa, Matt. Side note again, because I'm in that kind of mood. My wife and I just started watching Yellowstone. We're in like the 3rd episode, and a meth lab blows up. It's not a spoiler. It's not a huge thing, but have you heard of this show?
No, this is the first time I've heard it. Season 3?
It's one of those. Yes, it's on Paramount Networks, which of course nobody's ever heard of. But it's one of those shows that I keep hearing get mentioned here and there. Like, you at least when I hear about television shows, and I love television series like good TV.
Mm-hmm.
I'm going to try to lay it out for you what my formula is right now without even knowing I had a formula. But if there's what network is it on? What's that network's pedigree? Do they have a tendency to have it be good for 2 seasons and then be complete trash for 6 more? That. And I throw it all into the blender. I'm like, that sounds like a good one. And Yellowstone has been hitting those notes where just the right amount of people are starting to talk about it out of nowhere. And it's not a Netflix show, so you know it's going to last more than 1 season because the algorithm says it should be canceled and everything else. And it's not on Showtime, so you know it's going to be good for possibly more than 2 seasons.
There you go.
It's Kevin Costner. Kevin Costner as like the biggest ranch holder in Montana, and so he holds like a cattle commissioner position, and so he's under assault from a lot of it. There's developers that want to get in on that land.
Mm-hmm.
There's the Native Americans who got a new chief, so now he's trying to assert himself in all this. And how many shows do you live in that wilderness, not wilderness, but, country setting, ranch setting? Not a lot of shows have that. So already I love the atmosphere.
Yeah.
Like it's just,
Costner
is playing as like Field of Dreams type. It's awesome. It's awesome.
He's a pretty good one. I actually like a lot of his stuff. So that looks fun. I'll have to check that out.
Check that out. I would recommend it. So far, it's I'm still learning character names and getting used to who's who and all this. The dude from I think it's Hunger Games is the game maker from the first Hunger Games, the guy with a weird beard, dark hair,
big mustache. I don't know. I watched Hunger Games like once.
Okay, so is he the same guy as the brother from season 1 of Westworld?
I gotta look.
Yeah, what is it? The son of James Delos in Westworld season 1, dark hair guy. I think it's him.
I don't know.
Yeah, and there's probably some Yellowstone watchers out there listening, being like, "You idiot." It's okay.
Anyway.
Yes. So he's in it. Costner's in it. In terms of Danny Sutton's in it. You've seen him as in a lot of not Billions, but Succession. A lot of characters like, hey, I know that person. Cue Leonardo DiCaprio meme. Oh, pointing at the TV. But just a great show. So a little side note there.
Nice. I'll have to check that
one out. So yes, right tool for the job. Lasso might be the right tool in this case.
You got to know what the job is first.
So, yeah, our job wasn't so much build the lab. That wasn't really what we need to focus on. That, for what we do, is wheelhouse. Like, do it all day, every day.
How much CPU, how much compute? Yeah, that's not a hard one.
Right. But then from that standpoint, working with not only Shane, but now Keith, in terms of the requirements of one class over the other, are how Shane sees what we have set up and how Keith sees what we have set up or understands what we need from them, right? It could be completely different points of view. It could be a challenge.
There was a lot less with Keith's class and doing all of the virtualized networking inside of GNS3. There's a lot less network requirement to support because it's this one box and everything else is running inside of that. It's literally one segment for the pod. So where Shane's class has 6 or 7 segments, we've got 1, maybe 2 for Keith's class. So yeah, it's.
Is that because you're trunking all of those networks on the lesser segments, or it just doesn't require that? Fewer segments.
Because everything's virtualized inside of GNS, and GNS is just a single server. All of those servers that are in the pod have to connect through just one segment.
They're virtualized within the appliance inside that segment. So that handles the routing. It doesn't necessarily have to hit the NSX transport layer.
Gotcha.
That makes things simpler for you and us.
It does. Kind of kind of annoying because I was looking forward to doing some more fancy
Ooh,
network
a
stuff,
networking
but...
class. We can really show
Ooh,
it off
yay!
now.
You need one now. Oh, okay.
Oh. Well, I would say going forward, our classes will probably be a little bit more of that than Shane's vSphere iteration. I would gather it's simpler is going to. We're not going to need a ton of VLANs going forward. That's my guess.
Yeah, it kind of depends on what the class dictates, what the class needs. Like if we were doing an NSX class, we might need a bunch more networks for that. Who knows?
I'm just going to ask, can you nest NSXT?
Yes, actually, that's...
Oh, this is Inception.
Right?
Inception all the way.
Right? That's one of the things we looked at for how to make this class. One of the problems we had to solve for supporting these environments.
That blows my mind. But the nice thing is, given Terraform, building up and tearing down. Now, if we did an NSX class, would we leverage Terraform inside the class or not necessarily?
Well, I mean, I guess it kind of depends. We could. That's an option.
Yeah.
We could leverage Terraform
That's
inside the
tool.
class. I think that would be more along the lines of kind of like how Keith's is a network automation piece, and he's going to be touching a lot of Ansible piece. If we're going to be doing that, if that's the goal, and talk about how to, maybe it's a level 2 class where you've understood NSX and understood all of the components, and now here's how we can leverage it to grow and scale and do some scripting against it. That might be inappropriate, but I think for like a core class, it might be a little much.
Yeah, getting it stood up, you're not going to be automating that in your initial environment. It's once you've got things settled and you say, you know what, hey, I want to clone that environment out to a dev test environment. That's something where you can really start to script around that.
Yeah, there's some components that we're seeing. Like there isn't a Terraform component to deploy an edge gateway or an edge VM. That doesn't exist. You can go reference it because you need to install a route instance, a tier 0, tier 1 on it, but you can't deploy it through Terraform. You've got to have those pieces stood up before.
Interesting. That's interesting. I would assume that would be coming, right?
Maybe. I mean, there's that chicken and the egg thing, right? Here, let me define my environment, and now you can go use
what's your
resources.
base foundation? What exists? Right, chicken egg is
yeah.
Well put. So speaking of base configuration, how do we lay our lab out? At risk of breaking down the security by obscurity principle, Matt.
I mean, everything's RFC 1918 inside of there, so I wonder what my network segments are. I wonder what my address space looks like.
I guess there's a 172.16 somewhere in there. Is my
probably. So one of the problems that we identified and how we wanted to actually, before we get into that, keeping every pod segment and having the same addressing, let's talk about some of the core pieces to run the environment on. Realistically, it's all fairly small. There's 2 10 gig switches, 2 1 gig switches, 2 firewalls, a bunch of compute, and a storage array. I mean, there isn't that much going in there. If you're looking at a picture, if you're drawing how everything's connected, it's that box. It's those 2 switches, and they're connected down and across.
Cross-connected.
Down,
yep.
And bam, you're done. That's it. Nothing fancy, nothing special there. Once we get into the layer 3 stuff, we talked a little bit last time about how like the VMware validated designs have you carve up this whole separate management infrastructure and right? We were keeping it kind of small. We don't need that much. We've got the 2 hosts, and we did go a little bigger on the network adapters. So we were able to carve up 2 physical adapters for management, vMotion, storage, DVSwitch design. All of that stuff runs on those 2 physical adapters. And the routing for the management infrastructure is all handled by physical hardware. So just as you'd build a data center from forever ago, or for the last 10 years or however long, firewall, layer 3 switch, here's 10 VLANs, and it's, SIMC out-of-band management, it's vCenter, ESX hosts, it's the vMotion subnet, the iSCSI subnet, all of that stuff is all running on that physical switching infrastructure as a VLAN traditional backed network. So all of that sits there and it doesn't have any issues. The idea being we can completely lose power in the lab, power it up, and my firewall's going to come up, my switches are going to come up, and I can get to everything.
Access into the bits to then configure the other bits is always going to be there given power.
Yep.
That's me with, and I'm not denigrating NSX at all. I think it's cool, but it also extends to that DVSwitch in that there are caveats where, it depends on, or this could be a thing, or this could be a problem if you don't use ephemeral ports. Something about that just doesn't sit right with me. And I guess let's go to a day before Terraform existed, before a lot of these automation technologies existed. Now, scripting's been around forever, so given a sizable enough environment, you could always script stuff. But really, I think one of the main benefits of DVSwitch, in terms of architecture, is I create a VM port group once, and if I have 100 hosts or 60 hosts in my cluster, I create it once, not 60. If a standard vSwitch, I'm creating that port group on every single host.
Over and over again.
Which, of course, at that point, you would script via your architecture of choice. So DVSwitch is nice for that. But overall, I sleep better at night knowing that my storage, pinnings, and all of that are on a standard vSwitch.
Yeah.
And I think
still to this day?
What's that?
Still to this day?
Well, you have to create the VM kernel ports per host anyway, so you're not really you're not saving so much on time. But yes, still to this day, because I mean, you just mentioned VMware's reference themselves as a bare metal, 3 or 4 node dedicated management cluster without all the fancy bits. And I'm like, well, okay, if you're willing to go for that, then I'm willing to say, I'm allowed to say, the same. And consider the vSwitch old, traditional, faithful. That's just kind of...
So to be fair, the physical servers we got have 2 dedicated 1 gig onboard ports, and the management VM kernel interface is still sitting on vSwitch 0 on the default port group that's created, plugged into that network. It's still sitting there because it's ESX VM kernel interface, and why
is it not on DVSwitch?
How much traffic does that VM kernel interface generate? And it's sitting there.
Oh, I don't think it's traffic at all. I would say, what are you gaining by putting it on DVSwitch outside of maybe a little bit more risk? Maybe a little bit more risk.
So your trade-off there, it's kind of a mixed bag. That initial connection, right? Whenever that ESX host comes up, the only thing we need to do first is be able to talk to that VM kernel interface to interact with ESX. Everything else can get built and re-provisioned and pushed down to the system through that interface, and it's not gonna the benefit
it's
of
not
having
high bandwidth. It's not competing with anything really.
It's not going to try to rip the switching out from under it so that it can install this new thing, and you run into that, who wins, who got there first piece.
And it's not like, again, it's not like I'm taking a swing at DVSwitch, because it's incredibly mature and robust at this point, and with best practice design, those risks are more or less eliminated. But anytime something lives in software like that, where it's okay. What, again, like I mentioned in the last episode, when I ask a customer, what are we trying to achieve here? I'm trying to achieve the ability to have a VM or an ESXi host crash or whatever come up from power, and I know I'm going to talk on that port, and I can say that outside of the vSwitch being blown away by somebody who went in and reset the network config, or ESXi just straight up not coming up for some reason. It's going to be there on the vSwitch outside of those 2 weird configuration settings. DVSwitch theoretically
should be.
Should, but I and then I would look at it and say, let's say I did that and it didn't come up. I say, why did I do this? I didn't need to include it in the DVSwitch. It's not necessary. Outside of physical interface shortage. If I have 2 physical interfaces, that's it.
You kind of have to,
I have to kind of go one way or the other.
Well,
I'm going to be introducing a new piece of hardware into our lab, Matt, you and I, that we kind of play around and host our own stuff on I got a little 4-node box, but I only have 2 links per host.
You can fit a little PCI card in there, can't you?
I can, but that requires more money.
Oh,
Who wants to do that?
A couple $100 for 1 gig ports. There you go. You're done.
Possibly. We'll see.
There you go. So,
Yeah.
So we talked a little bit about how it's connected up, where some of that routing's happening. We've got a network. I'm personally a fan of what I call the routed network between the firewall and the switching environment. So that's where we start to get into the NSX, and we're leveraging NSX to build the connectivity for all of the pods. That's where, when you as a student log into, all of your network provisioning, network connections is done through NSX. So kind of at a high level, NSX is doing network virtualization, but what's that really mean? When we mentioned overlay at the beginning, the idea is, at scale, this all makes way more sense because I could have rows and rows and rows of ESX hosts in a data center, and I need multiple different networks underneath to just provide that connectivity on that physical hardware. And then I still want to be able to present a single segment, a single network, a single IP space across all of those ESX hosts, even though they might be physically connected to a spine leaf network that's not layer 2 adjacent for all of those clusters. So NSX is providing a function to be able to move the virtual networking up above the physical networking, hence the overlay and the underlay when we talk about the physical network infrastructure. So we've got what's called a tier 0 router plugged into that route interface, and we're sending an entire subnet, supernet /8 into that tier 0 interface, into the NSX. From there, I can send these pieces wherever I need to. I can start scaling things out. I can build multiple routers. I can have n number of routers deployed to an environment.
Okay. Yeah, the overlay underlay thing, that's kind of where I've seen some confusion happen. It's conceptually something that could be difficult to grasp onto, but it truly is basically it takes care of the physical bits underneath. So now it floats this new layer on there, and forget about what's underneath at that point. Just know it's taken care of, kind of thing, right?
Right. So we had a node in here, a TEP, a tunnel endpoint interface. If we've got 10 hosts sitting over here, and their TEP, their tunnel endpoint, is sitting on 10.0/24, and we've got 10 hosts over here, and they're sitting on 10.1, that TEP interface is going to be plugged into those, and that's what's encapsulating using, we've heard, you'll hear VXLAN, you'll hear Geneve talked about for encapsulation. That's where those devices, in our case an NVDS, is encapsulating that traffic, sending it down to the wire, and saying, I need to go to the TEP that's on the 10.0 network to get to that VM, even though it's air quotes layer 2 adjacent. That's how that's happening.
Does an NVDS need a VDS underneath it?
So we talked a little bit about that. With the 3.0 release of NSXT, we now have the ability to put all of these segments and all of the networking on a DVSwitch. So we can have the traditional DVSwitch and all the port groups we built, or we can deploy a separate network virtual distributed switch, or an NVDS. So there's an either or there. You either do one or the other, right?
Well, we ran into that, oddly enough, with our Horizon virtual desktop pods, in that when you create a Gold Master template that we're going to spin off clones of for student desktops, it will only see the NVDS switching. So we need to say student 1 goes to pod 1, student 2 goes to pod 2.
Was it that it was only seeing the NVDS, or was it that it had to source from the same type of port group?
That's exactly that's the issue. Yeah, where originally, like, so we built the Gold Master in our
3 or 4
standard
times.
lab environment, management network that's not a part of NSX, and we roll it up. So, okay, great. We go ahead and create the pod, and we use PowerShell to script the creation of the pods, and it was failing. So I went through the manual steps. Okay, let's see what this looks like. Click, click, click. And it gets to the point where, okay, what network do you want this pod to live on? And it would not show any of the NSXT segments.
No, it wouldn't.
What the heck, man?
That's weird.
They're there. Won't show them, which I saw everything else.
Yeah.
So what I went through, I went back and I changed the gold image to live on a placeholder. I think it's called a template. NSXT. It's a specific NSXT segment. Doesn't matter what network it's on. Doesn't matter any of the VLAN. Nothing. Just it's an NSXT VLAN
just so we
segment.
can have the same type, right? Yeah. I remember building.
So then you edit.
Yeah.
So then you edit. Yep. So the VM. Then you go ahead and choose your network, and lo and behold, it can see. And it's just, to me, it felt like, well, one, I think NSXT 3.0 was a major milestone from the 2.4, right? Because I feel like a lot changed there. And again, now you've got all these other VMware suite products that kind of have to play catch up or might run into I would wager down the road that whether it's an NSX thing or a Horizon thing, that gets fixed where it can see everything.
Oh yeah, I expect that to clean up. We're just right at that new edge.
Yep, we're on the edge. Mm-hmm. Exactly. So yeah, it's definitely stuff that when we turn around and we say, okay, who's done this before? Who's done some of these things before? The answer very well may be no one.
Yeah.
And you have to be okay with that.
Yep.
You have to be okay with that.
And we get ourselves into situations where, hey, we're going to start doing this, and you've got to envision on the other side of that that coin the people that are the developers that are writing NSX, seeing what people are doing and going, wow, I didn't expect that to happen. I didn't expect that to be a use case. Let's call that a good idea and incorporate it. One of the ones I expect to see come down as an actual switch, because you can't do it unless you call it like from an API, is changing the MAC addresses of the TEPs underneath, so that you can run nested NSX. Talk about network inception.
Okay, I just had Inception, except this time I could actually hear the dialogue in the movie. Help me on this, Matt. Either go again or go better.
Go better. Go gooder. Do more gooder. So those endpoints have to be able to talk to each other. Those TEP endpoints have to be able to talk to each other. Of course. Right? Just like with ESX, when we build a VM kernel interface, we've got that first set of the MAC address that's VMware specific. So we end up with the same kind of thing in NSX when we deploy our TEPs. So there's a setting, which we did in our environment on the base transport zones, the base overlay transport zone, that changed that MAC address field from the default to the default +1. I don't know what it actually changes to because it doesn't matter to me. So that when we build yet another level underneath it, those two MAC addresses don't exist on the same network at the same time. Yeah, we don't have that kind of an issue. So stuff like that to set that
I ran
setting.
into a weird thing, Matt.
Mm-hmm.
This is not NSX related, but similarly from a network virtualization standpoint, at my last job, and this was a good 10 years ago, my company had an office in Stokenchurch, England, which is about 40 minutes north of London. And literally it was a building with gig fiber in to the building, and out the back window was a pile of cow shit. And people were pheasant hunting. So it was just this rolling hill. It was amazing. It was great. It was just like, okay, this is really a weird mix of industry, let's say. So we had turned up our circuit to like 100 meg, something like that. And I was doing, and the speed was atrocious. We weren't getting that, not even close. And I was working with British Telecom from the United States at this point. We had already flown back, and we're going back and forth, and the speed is whatever, and it's just terrible. And so the ISP finally would get me a guy he stood up an iPerf 3 server, right? So here's a box I can hit that stays on your network. And so we would run like a UDP throughput test and get all of it.
Mm-hmm.
The second we did a TCP throughput test, here's our issue. Oh, okay. Well, they saw that there was an issue, but they weren't able to fix it. Well, Google came to town at some point and were running a convention or something, and they hit it. Well, guess what got fixed real quick, like
overnight, yeah.
When the Goog ran into it. So I'm going to paraphrase, and I'm quite positive I don't know exactly what the problem was, only what they told me. But essentially, on their MPLS network, there was some kind of duplicate or and it could have been the IP, some kind of address looked like another address, or was translated onto another address, and it was causing packet loss. And UDP don't care; it's just going to send, and it got all of it. But TCP needs an acknowledgement to consider it throughput at that point and build up some flow. So that was an issue. So yeah, MAC addresses uniqueness and all of that kind of stuff.
That makes a difference, yeah.
Yeah.
So that's some of the growing pains we had. We haven't actually uncovered the secret sauce of what we're doing for the network and how we're making those pods. So let's do that real quick. We've got there's in NSX there's a context of the tier 0 interface and the tier 1 interface, or the tier 0 router and the tier 1 router. The tier 0 interface the tier 0 router is the one that is going to interact.
It interfaces with your physical stuff, right?
Yeah, it's the one that's going to interact with the physical environment. It's that ingress point. You could say here's two completely separate customers and route them between their tier 0, but it's that edge, it's that border router.
It's NSX's go between. It's the meet me room for NSX and our physical underlaying infrastructure.
Yeah, that's a good way to look at it. So in our environment, we've set up a single tier 0 router, which gives us a point to push this entire subnet to, this entire supernet that we can then carve up for all of our needs underneath that, and we don't have to do any route changes because it's that one point and that tier 0 never changes. And then for each pod we deploy, we create a new tier 1 interface, or a new tier 1 router. And on that tier 1 router, through the magic of standard routing lookups, we're able to create a network that is the same on each one of those tier 1 routers.
Because that tier 1 router is essentially the meet me for a customer environment, a student environment.
Yeah.
And its handoff is not to our physical interface, it is to that T0 router, which is essentially the meet me room between NSX and physical.
Yep. So the things that happen, there's a couple of extra things that have to happen there to support that. Obviously, if we've got this big dynamic routing environment and we've got segments that exist all over the place, we'd run into some issues. So we're doing those tier 1 router with all of those segments being the same address space. We've got to, on the egress interface, we've created a NAT rule to say anything that's, in our case, 10.0 gets natted outbound, so that those routes don't clobber the other routes on the tier 0 interface. We've got a VDI network that's unique to each one of the pods. And then because the VDI and the pod segment, the actual VMs that we're touching and working on, are on the same router, the router will look up and see that it's got a 10.0 that's locally connected. So there's your connectivity into your pod. Your VDI connectivity is routable all the way through. Your VMs in your environment can get out and request stuff from a file share or DNS or wherever because they're natting. And then a handful of security rules that say you can get here or you can't.
So so there has to be an underlying uniqueness between the pods. That's at the tier 1 layer, right? That would be a 10.1, a 10.2, a 10.3 kind of, or 10.1.1.
Right. So the link between the tier 1 and the tier 0 is unique. That's just a point-to-point like /30 routed link, right?
But that tier 1 router has to have some kind of unique address. It can't be the same as the tier 1 next to it.
Right. So the two unique things about that are the VDI pod has its own unique subnet per pod, but you don't care about that because you're just routed in and there's your workstation.
Sure.
And then the NAT interface is unique per pod. So you can guess the NAT interface is here's your subnet, and your NAT is .1, your NAT is .2, your NAT is .3, right? So that's
and hey,
how
you just increment it with the count variable in Terraform.
Right, +1.
Ta-da! It was fun. I remember, I think you were on PTO, Matt, and we were in the process of building up the underlying skeleton for what this looks like, and you had deployed NSX. And really, it's okay, Mr. Yeti, go in there and set up the segments that Shane's
for you.
Yeah, and it was basically I was supposed to hand it off to Shane and say, okay, let's test creating 4 of them and what that process looks like, and we'll get to the Terraform later. Let's just get Shane through his first class and we'll do it. And I said, you know what? I'm gonna spend the effort. The hell with doing it manually. I'm just gonna see what this looks like with Terraform. I'm gonna dive in. Kazo's talked this Terraform thing up. Let's see if he knows what he's talking about. And maybe, if all things fall down and it crash, at least I can go back and hit him over the head with that, and have a win on my hands anyway. Kazo comes back from vacay and, hey Matt, we're deploying 20 pods with Terraform right now, and
bam, we're done.
We had plenty of the fine sanding to do after that in terms of. This VM depends on this VM being up first, so we found out how to do that with Terraform, and a lot of fine tuning actually. But but it's like I can live in that world forever. If it's the heavy lifting, it's just getting the big chunks of stone underneath me, and now I can stand on it and turn that screw as many times as it needs to. If I can get to that point, then I feel like I've gotten over the unknown hump. Right? I had no idea what it was going to take to get anything running in Terraform. But now that I got past that point, now I can really focus my brain power on the finer stuff. We've gotten over that big hump, and that was a good feeling.
I thought it was super cool to see you go, oh, this is super cool. Look at how many. Look, let me change this variable from I want 10 of them to I want 20 of them, and just hit go, and it works. Right?
You experienced how I learn. You can whiteboard and show me this and show me that, and hey, this is cool, and let's read this feature list, and I'm like, yawn. Wonderful. Show me how it practically helps me. That's how I learn. So going through that, I'm like, oh. And that's why we've talked about it on this series, on this podcast. It's so tough in a home lab because you're talking to me about, I can throw out this Plex Docker, and if it crashes, I can just spin up another one. And I'm like, Matt, okay, my Plex has never crashed.
Right.
It shouldn't crash. If it's crashing, something's wrong, and I want to be able to get in there and fix it. So the idea of spinning up Kubernetes in my lab, I got no application for this. I've got no need for 37,000 Plex servers. I just don't. And so it's tough to learn when it's just an academic exercise at that point.
Yeah.
But when I have a practical need and a pull, it's like, yeah, let's get mad scientists on this. This is awesome.
Having that problem to solve, that's one of the things I like about doing the consulting work is I get to go talk to customers and work with customers, and everyone's got a unique problem. A lot of the solutions are fairly similar, but we still have to solve it for them, right? So now we have a problem that we have to solve for us, right?
That word that you use is what's caused the DevOps thing to simultaneously explode, but also be incredibly difficult and challenging to come up with the right tool. Because everyone has a slightly unique need, or most people do, and whereas, I want to run servers and I want to, therefore virtualize. I want to leverage a hypervisor. VMware is a massive hammer that hits almost every nail that you swing at. Like, it's just, there's a reason why it is the massive market leader, and every third-party software plugs into it. It's the way to virtualize on-premise. And some would argue in the cloud, too. It's just certainly an option. DevOps, you've got software developers who've been kind of had a running start, had a walking start, a jogging start, and they're doing it this way or that way or the other way. And now we're coming in and saying, hey, let's look at Terraform. Oh, but I already have this. I'm already doing it this way. And even like, we wouldn't take our Terraform stuff, Kazo, necessarily. I think we're probably better suited than most, given that but we have our needs, right?
Right. We're solving our problems, not someone else's. And I think there's things that we've seen.
Even though it's a framework, it needs an incredible amount of customization to be relevant for that user. And I think that's the challenge. But that's what we can help with too, which is good, which is why this lab exercise was so important.
Right. I think that's the piece that we see is how can we apply this to you? How can we use this tool? Ideally, like I'd love to be able to say, roll up with my laptop and plug in and just run my script and bam, I'm done.
I know you've talked about that. Yep.
I don't know. That's not gonna.
Well, what I'm working on really is in my spare time, right? Is basically a when we deploy or upgrade a virtual environment. Most of them are upgrade now, but not many people are still just freshly virtual, although it's still out there, right? And I love that conversion from what is
a virtual machine?
Right. But the idea is to have basically an OVA or an appliance that's running on CentOS or something, free. Oh, an Ivoxy assessment, an upgrade assessment, and a upgrade operation. Oh, and here's a new VM on your network. Oh, it's got Ansible AWX, which is the open source version of Tower.
Mm-hmm.
Maybe play around with this. Maybe it's got some Terraform on there, maybe some PowerShell scripts. So just here's how you clone a VM.
Mm-hmm.
Punch it in here. And it's just maybe people get that itch and they see how they can possibly use it, and that way it gets you off the schneid. It gets you off the starting block at least. And I think that can be the hardest part, is get it moving to some level of here's a practical thing.
Here's
and
a
the
success,
step between
here's a something you
ground
can do
zero
with it,
and a practical thing is a big leap to start with. Once you
is.
get there, it's like, okay, I can see where I can tweak and do
Right.
this. But that's a big first step. And if we can prevent you from pulling that hamstring on the first step, all the better for everyone, right? Yeah. So definitely reach out if you've got thoughts about starting or what it looks like to build a base. It doesn't even need to be, I need to hit a home run. How do I hit a single? How do I lay the bases down first? And then maybe I can start looking at what my positioning goes.
What's that core? What's
we
that
can
one
certainly
thing?
help with that.
Yeah.
Yeah.
Absolutely.
Cool. Maddie, thank you for walking us through the NSXT stuff. This is fun. I'm liking the series an awful lot.
I know. It's fun to have a exciting nerd topic to talk about. It's this or home automation, right? That's the two big ones right now.
And like I say now, automation isn't necessarily about automating something. It's about standardizing things.
Yeah. I like that. I like that quite a bit.
Well, it is, right? Because that's my home lab argument. What do I got to automate? I don't got to automate anything. But when a year goes by and I haven't touched it and I say, shoot, how do I do this again? And I just go, oh, it's all stateful. Do it again. And because you're always missing something, right? And your hand's not always in the cookie jar every single day.
Because we are fallible human beings.
Yep. Oh, quite. Well, Keith has his network automation class. What do you know when that's scheduled for, Matt?
I think we're looking at January.
January
for that. Yeah.
Yep. So if you're listening and you have an account manager, reach out to your account manager if you're interested in that automation class. If you're listening, potential new customer, you're not that familiar with us, hit us at podcast@ivoxy.com. That will get to us, and we can make sure to get you in touch with the right people about that to reserve your spot for the class. So, subscribe to us if you aren't already. You all know wherever you listen to podcasts, just hit that subscribe button, smash it, even if you would.
Smash it with a sawzall, right?
With a sawzall, yeah, the right tool for the job. Keep that away from me, yeah. Mr. Coslino, thanks for joining this morning. Always appreciate you. Have a good one. Thanks for listening, everyone.
Bye, everyone.